Is that correct? Now, if that is the case, they add up to 19, right? So I really am failing to understand how you are getting a 25 here or a 15 or I don't know. Okay, it's a 25. So, I mean, is this part of the data? Part of it is not visible. So maybe there is one more class interval here which is not seen at all. So overall, you can understand what I would feel about this homework. Okay. I mean, if you're using class interval here, why not use the same thing for histogram here? Okay. Okay. Now this one is very interesting. Very neat work, which was big relief. At the same time, what I found very interesting is, this is where I found you manufactured data or kind of, tweaked around. I feel the frequencies was taken so that it is deliberately at this border. I don't know whether that is true, but it is deliberately taken like this. I would say change the frequencies slightly, just make this, let's say, make this 9 a 10 or make this 12, 13 or something and see what happens. Okay. Change any one of them slightly and see what happens. Because right now you are not using the histogram concept that I told you about having the area. You are still trying to use the discrete situation. Okay. I mean, I'm glad you're trying to see that, but the thing is that, when you clearly see that when you're looking at continuous data, then you don't look at half of the frequencies, not 23, it is 22.5. And so categorically, what is the median class? Go from there. Okay, don't approximate, then you're missing the point. There is no point trying to drag it back to a discrete case. Okay. Now, yeah, anybody would like to share something? Okay. Now, in this case, I mean, again, a pretty good attempt at getting the ogives, etc. I'm failing to see what is this point doing here. I mean, if it was done by mistake, cross it out or do something. And if you actually try to see what happens, okay, and because the data was given, I actually tried to see what happens. This is what is happening here. Okay, these are using the exact same data points. Now, as you can see, I mean, the way you have drawn it, you have hand drawn it, so you can approximate, right? And you make the median exactly at 8. That is an approximation. But the moment you try to prove the same thing in GeoGebra, I'm basically plotting these two, 7 to 8, and these two, 7 to 8. Okay, you can see that they're intersecting. Yes, the intersection is very close to 8. Okay, at the same time, it is not at 8. It's very, very close to 8. It's 7.945 something, probably. Yeah, it's not at 8. The whole point was to, try the continuous case, the class with class intervals. So again, as I'm saying, just try to do it with some other, change the frequency slightly and see what happens. How the graphs change, what happens. This was to me, it appears to be a deliberate case to, again, same thing. Why are you taking 7 to 9? Where is the 8, that point, 823? Where is that point? Why is it missing? It should not be missing. And if you're using n by 2 is 22.5. Use that. Okay. Again, the whole point was to derive this formula. I don't see how this formula is connected to this graph. There is some approximation. I mean, I like the neatness of the work, the effort, but don't try to approximate things because it's not going to be generalizable. So, okay, be careful. Now, this is where I got very puzzled. First of all, when you are scanning, please make sure this is rotated. Otherwise, it really makes life tough. Now, if you have such a data, why didn't you use this? Where is the word corresponding to this? I would strongly recommend, you repeat the work with this data and see what happens. Because maybe then you will be forced to see here, nothing is borderline 30, right? Half of 60 is 30. You can see that it's not borderline 30. It will be in this 30 to 40 is going to be your median class. Okay. And if you actually play with this data, you will get it. So I'll strongly recommend that you do it. And whether or not I assign the homework this week, do it. Okay. 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 Very nicely done, etc. The data is given. Nice histogram. Okay. Now, where is the work supporting that it is this interval? Okay, that is not here because you have not done the cumulative frequencies. Okay. Okay, this is fine. Okay. It's not frequency of class. You have to see where this 19th frequency is. Okay, and that is where you need the cumulative, which you have not done. Then there was nothing else done. So the whole point is not to find just the median class, but then halve it. So you have to halve this histogram, and that will be a line through this box, this rectangle. Where exactly, that is where I thought you will be able to do it. Okay. I mean, what will be the total area. Okay. These are all 10. Okay. So this area is 50. This is 80. This is 100, like that. Okay. And so the total frequency is 38. So the total area is 380. Therefore, half the area will be 190. Now let's see, this will be 50, this is 80, together 130. So how much is, so 60 out of 190, 130 is coming from here. So 60 is left. So 60 will come from here. Okay. So this, what is the height? So what will be the width? And that will tell you exactly where this line will pass. That's the work that was left and the critical part. Okay. Again, cumulative frequency part, beautifully done, like the color coding and everything. Okay. Now, where are you getting this? Okay. I can see that you have done a nice graph, and there you can see this line, etc., which is fine. So you probably need to mention here that these are observations from the graph. Okay. But that observation is good. Okay. And because you have done such a nice job, that's very nice. But where is the deduction? Because this part of the homework was, let me remind you, derive the formula. The derivation part is missing. And the reason I pushed you towards this is when it came to the mode, Most of you derived the mode formula. So I thought you will be able to do the same for median. Okay. So, I mean, you have these 2 points, etc. Now, so as I look at your pictures, there are many ways you can get this thing, and we will talk about that. Okay, but very neatly done, and when you do such a neat work, it really helps in many other ways. For example, here you can clearly see that these 4 points, they form an isosceles trapezium, right? Where the vertical side trapezium, and these 2 lines are basically its diagonals. And by the symmetry of isosceles trapezium, they have to intersect at the line of symmetry, which will be, passing through the midpoint between these 2 and the midpoint, midpoints of the parallel sides. And from there, you automatically get that n by 2. Now, there's one more thing that comes to it. Where are you getting the n by 2? We'll get to that, because there's one's homework which we'll talk about that. Okay. And let's see. Okay, so this is fine. Okay. And now, without the coordinates, this is a very, very imprecisely drawn histogram. And there's nothing, nothing is there. Here you have the data. It's not getting reflected here. Okay. And what do you mean by mean of median? Hello, what is that? And first of all, I have no idea what you mean by mean of median. Second, n by 2 is not the median. N by 2 helps you find the median. It is not necessarily the median. And in this case, it is definitely not the median. Okay. So you need to look up your understanding. Okay. Again, there's no data given. And this is not the graph of this data. Okay. Here the intervals are 5 to 10, 10 to 15, etc. Here the class intervals are 6 to 6.5, 6.5 to 7, etc. So, what happened? Okay. And again, it's not very clear what you are doing. The process is not at all clear. I can faintly see one line here. Okay. But where is the work supporting that? That, okay, this is the area of the, this part, and the whole area is this. That work is completely missing. So I would say that this is incomplete. It can potentially be completed. Okay, but right now it's not making much sense. Okay. At any point, if you have any question, any doubt, any comment, please stop me. Okay. Okay. Very neat, very precise. Okay. And I could make out that you have made the intervals continuous. That's perfectly fine. Okay. And then again, very neat graph. Okay. So that's fine. The thing is, all our handwritings become very bad when we try to, use the mouse to write. So I can see that you have derived it. Excellent. And I hope you will help others understand your derivation. Okay. But this is exactly what I was looking for. Okay. So you have plotted based on your data, then you have generalized. Okay. Very good. Okay. Sorry. Okay. Now here it was something very interesting. So there are several things I want to mention in this slide. First of all, how did you manage to get C equal to 1? The slope, okay, fine, you get the slope. How did you manage to find C equal to 79? It's not given at all. And there is a reason why I'm asking this.
I have taken from the GeoGebra. Just I pointed the line segment and take it.
Oh, I see. That's good. I like that. And that can work. Okay. The thing is, what you need to be very careful here is look at the syllabus and see if y equal to mx plus c is there in up within class 10. Okay. The coordinate geometry up to class 10 is pretty basic. I'm not sure if it has all these treatments of y equal to mx plus c, how to find m, as y1 minus y2 by x1 minus x2, etc. So if it is not there in class 10, you cannot use that. So you have to find out. So you are in some ways restricted by the syllabus. And that is a very, very interesting feature of school mathematics. You have to go with what the learner knows. You don't have all tools available to you because the learner doesn't have all tools available to him or her. Okay? And it doesn't make sense to, teach them things they were going to learn in 11 now. You can't scale it up. Okay? And all children may not be able to do that. So what can we do? Is it possible to solve this within what they know using the tools that they have? Okay, so that's one thing. Okay, and this is where often when people who are very good in math come to school of mathematics, they fail because of this. When they think of math problems, they are using all the tools they know, but a child may not. And therefore, to bring yourself down to the level of the child is not necessarily easy. Solving a problem with minimal tools. Okay. Now, your example was very, very interesting, and I cannot stop but annotate. Okay. And I had to go back, and if you look, what kind of a quadrilateral do you see here? Anybody?
So it's a rectangle, a parallelogram.
Exactly. It's a rectangle. And that is corroborated by the coordinates.
Yes.
Right? Now, if it is a rectangle, your job becomes so much more easier. The diagonals of a rectangle intersect at its center. Right? Rectangle is a parallelogram, therefore, various things can come in. And they bisect each other, they are equal. And from all of those things, you could deduce that, the y coordinate of this point, that this point is 35 something. 35 being the midpoint of 30 and 40, and the other way will be the midpoint of between 23 and 37. And in fact, because I saw this, I was like, did I miss this by any chance? And then I realized, no, you won't necessarily get a rectangle always. Most of the time, what we will get is isosceles trapezium. That is guaranteed. And some isosceles trapezium, as we had discussed, if I remember correctly, are rectangles. Just like some kites are rhombus. Okay. So that was a very interesting thing. And I don't know, I don't know whether it happened by chance or whether you chose your data that way, but it was very interesting to find the rectangle. Okay.
Swati, actually, I have one question. Can I ask?
Yes, please.
When I used to draw like a OG, less than OG curve and more than OG curve, I used to see like trapezium, parallelogram like that. But just now I'm seeing a rectangle. So rectangle will come always, or just
It doesn't
mirror?
come.
Yeah.
It doesn't come. See, okay, let me draw a few more and you will see why you see not only trapeziums, you will actually see isosceles trapezium.
Yeah.
Okay, see this one that I have drawn, this is isosceles trapezium.
Yes.
Yeah, see, because the vertical lines are always going to be parallel because they are both vertical, right? And the other two are mirror opposites of each other because it's the slopes are, one is positive, one is negative, and one is m, another is negative m.
Yeah.
Right? We talked about how it is like the frequency for the less than ogive and negative frequency for the more than ogive. Right? So that is why, it is always, when these are going to be always going to be isosceles trapeziums. Always. And in your case, by chance, they happen to be a rectangle. Special case of isosceles trapezium.
Yeah, I understand.
Yeah, it was very interesting. Okay. Okay. Okay, let's go to the next page. Yeah, so when this was from the slide that I had shared, and then okay, so rectangle is not general, but as you can see, ADBC is an isosceles trapezium. Okay, and because it is so, then a lot of things automatically fall in place. Now, this is, I think, I found this to be very interesting. If you look at M and M dash, you have claimed that it is equal to N. The claim is correct, but can you justify why it is so? For example, what is N? Okay. This M is the y coordinate of A, right? So M is number of, it's the cumulative less than cumulative frequency corresponding to for L, right? Which means number of data points less than L, right? Okay. And then think about what M dash is. That is more than cumulative frequency for L again, and that is equal to number of data points greater than L. Now, somewhere here, either it depends on how the class intervals are defined. Either there will be an equality here, meaning less than equal to, or there will be an equality here, meaning greater than equal to. That varies from case to case, but the equality will be there somewhere. Now, if you think about it now, number of data points less than L plus number of data points greater than equal to L. Doesn't it cover all possible data points? So this is the reason why this M dash plus M is equal to N. Okay. It is a very correct observation, but you need to substantiate this with reason why. Okay. So then it is more clearly linked with the meaning. Where is this coordinate coming from? Okay. So that's how, they kind of fit together very nicely. And once you get that, then n by 2 is obvious because it's the midpoint. Okay. So I think I will have, and let me clear this. Oops, sorry. Hang on 1 second. Yeah. Okay. Now this one, I found it again to be a bit doctored in the sense that your median is exactly at 35. I mean, I would have preferred if it was 34, 33 or 37 or something like that. But this exact 35, is a bit suspicious. But as far as what you are supposed to do, those things perfectly bang on right, no complaints. Okay. The only thing is this cancellation of F. Okay. I think it will be good if you take a look at this. It may happen in your particular case, but I'm not sure if you can easily cancel out this, so easily. In your case, I believe what happened is the sum of these three rectangles, of height 3, 8, 12, and the sum of these rectangles. So 3 plus 8 plus 12 is 23. And out here we have 2 plus 5 plus 6 plus 10. That's another 23. So again, you got lucky, or you deliberately tweaked it to get here. Okay. So what you have here is a special case. It may not happen for any histogram. In your case, because, everything kind of canceled out, balanced out on both sides. Therefore, you are left with just the median class and the corresponding rectangle, which you are having. That may not be the case always. So try changing the frequencies a little bit and see what happens. Okay. Because when you are trying to derive a formula, you need to take the most general situation. And you don't try to make your life easier by, tweaking and making things simpler. So, is that part clear?
Yes.
Okay. Okay. Okay, again, very clearly mentioned what is happening. Now, this is what I will call a very, very proper diagram. You see the areas of each rectangle is mentioned. Okay. You can see that they add up to what? The total area is 300. And then you can see that, so this is 140. So you have 20 left. So that needs to come here. Okay. Now, if this is 5, then how much should this be? And you can kind of figure it out. Okay. So this part is perfect and not a problem at all. This 7 to 2 is correct, but I think you need to show a bit more work and you need to generalize. That generalization part is missing. Okay. Otherwise, this is very, very clear for anybody to understand what is going on. Okay. So the way you do it is, this is L. Okay. And this is the cumulative frequency till L. So you use that. So if you want to consider these two rectangles, that is going to be the common C. C is the common length, right? That 10. Let me do the special. Okay. And then you have 5 plus 9. Those are the frequencies. Plus you have this rectangle, which is going to be m minus 70 times 5. And that will be equal to 300 by 2. Okay, and 300 is total frequency. Okay, so 10 times 30 and divided by 2. Okay, and then what you get here is, now from there you can deduce, but if I now call it, if I remember correctly, class interval length is C, right? Can you help me remember the formula? Okay, maybe I should just take a look at Vasant's. Oops, sorry. Okay. Okay, let me. Okay. Yes. Okay. F is the cumulative frequency till then. Okay, got it. Okay. So this thing boils down to this is C times cumulative frequency plus m minus L times the frequency of median class equal to C times capital N by 2. Okay. And now if you do some algebra, you will see that m minus L this is C times N by 2 minus the cumulative frequency. And then I think, and you have to divide that thing by F. Okay, so then this goes, and then you have to add L. That takes care of this. So that's how you get the formula. Okay, and which comes basically from this step here. Okay, so this little work was missing. Okay. Okay. But very, very clear picture, Mane. This is very helpful. Okay. So I'm glad to see you're taking the same data. Now, again, very, very clear. I mean, this is not drawn on graph, but very, very clear picture. And you can see that, you know, they intersect close to L, close to these 2 points, but not exactly there. Okay, that is coming out beautifully. Okay, and again, when you have a clear picture, again that isosceles trapezium pops out to him. And once it pops out, you have more tools to, you know, utilize. I mean, isosceles trapezium is something whose properties can be explored, given the geometry a child needs to know by 10th standard. So those are all accessible, doable, you know, very allowed things. So, but until and unless you have a clear drawing, you won't be able to see that. Okay. I know many people say math is abstract, etc., but you know, a clear picture helps you see. Okay. And again, I can see some geometry coming up here in terms of equal angles and stuff. Well, nice to see that. And that basically, again, solidifies the sense of similar triangles and stuff. But as I said, the the derivation part is needs more work, but that's fine. Okay. So that's for most of the homework. Now there's one more homework left, which is this one. Okay. Again, very nicely drawn. Now, one advantage of GeoGebra is that it gives you the answer. Use that, okay? But don't stop at that. Like here you've got the median, exact up to 0.75. Very, very precise. Okay. And here again, I can see you do this, but okay, so this also is equivalent to, okay, I can see some of the points mentioned, not necessarily all. For example, this is L cumulative frequency, that is very clear. This is median n by 2, very clear. What about this point? Don't you need that in terms of, L plus C and capital F plus small f to get this? And similarly, this coordinate. So what I can see is part of this derivation work has gone into this, but not complete. Okay. Okay. So you have used D instead of C, which is fine. Okay. This is this. Okay. F. So yeah, this is also pretty good. But here what has happened is you have gone the other way. I can see that you have got the general formula and then they have plugged in value and got the same value that you had got earlier. I believe you can back here, you are capable of deriving this if you haven't already done it. Okay. So yeah, good. And then now here you're using the formula. But this is where I would like you to link it to the histogram. Okay. Again, very glad to see same data has been used and so on and so forth. Yeah. So those things are excellent. But, don't blindly use it here. So try to relate this to this. And I've already showed that to you for another data. So see if you can do the same yourself.
Okay, Shruti.
Okay, so I will stop share for now. So as I could see, many of you have attempted the homework. Some of you did a fuller job and some of you did partial job. Okay. Oh, sorry. Okay. So what I would like you to do is, where the gaps are. I'm going to send back the homeworks with comments immediately now after we finish. So those of you who want, you can, try to take a more general data where you have got special cases like the rectangle or, things are very symmetric, etc. You can try to look at a more general case and see what it is. You can look at where you needed to do more work and see if you are able to do that. Okay. So, but those are all optional. I'm not going to assign anything. The more important thing is, what are we going to do next? Okay. I think as far as statistics, data handling is concerned, we have done quite a bit. We have done a lot of work on quadrilaterals in particular. And very interestingly, the quadrilaterals showed up here as isosceles trapeziums. And frankly, as I discuss these with you, today is the first time I thought of the isosceles trapezium. couple of months back when I was sharing these ogives, both ogives together with a bunch of kids, this symmetry and the reason for symmetry, same run, one rise being the reciprocal, I mean the opposite, additive opposite, negative of the other, those things became clear. And now today, when I saw your homeworks, the isosceles trapezium became very clear. Okay, so this interaction enriches me as well. So we have around 12 minutes. Can we decide, what you would like to discuss next? Or any question that you may have, anything?
Swati, actually, I have one question which I asked in Signal. Is about a number only. Can I ask?
Yes, please do.
There is a rule for finding a number that is divisible by 8. Yeah. So like a last 3-digit number, if you add
Yes.
and
Divisibility rule of 8. Yes.
Yes, divisible. But what about 9,000?
Yeah, 9,000 is divisible by 8.
Yes, but there is a digits are 0, 0 and 9, no? So when you add,
so you don't know the rule completely.
Yes, that's the thing. For 9,000, I don't know.
Okay. So this is how it goes.
Yeah.
You see, 9,000 is, okay, let me just use the whiteboard and write. That maybe make life a bit easier. Okay.
Yes.
Okay. Okay. So you see 9,000 is 9 times 1,000.
Yeah.
Right?
Yes.
Now, if you factorize 1,000, what do you get?
We can like 250 into 4 or 200 into 5.
Okay, let's see,
Like
250 into 4.
Yes.
Okay. Now 250 is an even number, right?
Yes.
So if we split it into something times 2 times 4.
Yeah.
Yeah.
Yes.
And then you can clearly see that it is now 9 times something times
into
8.
Yeah.
Yeah. See what happens is 1,000 is 10 times 10 times 10. Right?
Yeah.
Which means it is 2 times 2 times 2 times
5 times
5 times 5, right?
Yes.
I'm using a lot of commutativity and associativity here.
Yes.
Okay.
Yes.
But basically, this is why you get an 8.
Yeah.
It's 8 times something, right?
125. Yeah.
Yeah. So basically, you look at 3 digits. So if you have any number, let's say 47,256, right? You can always split it as 47,000 plus 256.
Yeah.
Now 47,000 has to be divisible by 8. Right? Because it's a multiple of 1,000. So all you need to do is check the 256. If that is divisible by 108, then the whole thing is.
Okay.
Similarly, 100 is, 4 times 25. So if you are looking at, divisibility rule for 4, you need to check the last 2 digits. So if you have, 783, it is 700 plus 83. And well, 700 has to be divisible by 4. Now, if 83 is divisible by 4, the whole thing will be. If 83 is not, then the whole thing won't. Yeah. And exactly the same way you can now get to just this. And then, if you have, let's say 74, that's 70 plus 4. So again, 70 has to be divisible by 2. And then you check the units digit.
Yeah.
Okay. So can you see the connection?
Yes.
It's just powers of 2.
Yeah.
So now you can devise your own rule for 16.
Yes.
Okay.
Yeah. So actually, when we do for like a simple 4-digit number or 3-digit number, last 3 digit numbers, like addition, it becomes 8 like that. But for like 6th standard kid, how we could explain this 9,000 for 6th standard student?
Okay, so first of all, divisibility by 2 and divisibility by 4 are important because they help you speed up calculation.
Yes.
If a child understands divisibility rule by 4, then you can extend the pattern to understand divisibility
Or
rule
4.
of 8.
Okay.
Okay.
Yeah.
It's that one more 2, 8 is 4 times 2.
Yes.
Right? So you are using 100, now you multiply it by another 10 to get 1,000.
Yeah.
Okay.
Yes.
I'm going to share the link for an article. If the link doesn't work, ping me, I'll send you a better link.
Yes. Yes.
Okay. So let me just hang on. 1 second. Let me just get you that link right now.
Yeah.
This is an article on divisibility only. I mean, explains the divisibility rules. Okay, I think the link is going to be fine, no matter what. It may look very boring. Okay, where is the chat? There. But just download the PDF and read it.
Yes. Yes.
Okay.
Yeah.
I promise you that PDF will have some nice pictures. So, I mean, raising these kind of questions are super important because sometimes, I mean, the way math is taught in most places is to be very rule-based. And if you don't understand or remember the whole rule, then, it stops making sense. So please take this opportunity to clarify those kinds of doubts. We have 4 minutes, so anybody else has any other question, feel free to ask. Okay, just wanted to give you a heads up that on Friday, 1st October, I have a whole day meeting, so I won't be able to do this class. And I doubt if you guys will be able, anybody will be available on October 2nd, Saturday. It's a national holiday after all. Okay, so that first week of October, we may have to skip. That we do have, I think, at least 1 or 2 weeks before that.
Next week we are meeting.
We have next week, yes. So let me know what is the topic that you guys come up with. And please share the topic at least a day in advance.
I'll share it.
Okay, if nobody has any other question or anything, we can end today.
But actually, I have one question from Ritik
Ask.
Hazara.
Ask.
Yes, yes. Actually, on 15th webinar, no, in YouTube, from Ritik Hazara, thought about the numbers, square roots.
Yes, yes.
So from there, how we can interrelate the mathematical induction to combinations? This is what I asked in the comment section, but I didn't get the answer.
Hang on. Can you repeat your question again?
Like when she talked about the numbers, no, the squares, roots, like that. So promptly I had a question like how the mathematical induction and the combinations are interrelated.
I didn't see this question. I was managing the chat.
Oh, okay.
I don't remember seeing this question.
Maybe
You're talking about this Wednesday's webinar, right?
Yes, yes, yes. On 15th, no?
I don't remember seeing this question. You know what? Why don't you email me this question or just type it up in chat right now?
Yes, I will send an email through that.
Okay, okay.
Yes,
Please
yes.
do.
Yes, yes. Okay, thank you, Siti.
Okay. Bye.
Thank you.
Thank you.
Thank you.